Now it's your turn to solve an equation using factoring and the zero product principle. Stop this video, take a moment to write out your answer to this problem in your lecture outline packet, and then turn the video back on to check your answer. For this problem, we're told to solve the equation y times the expression 3y plus 2 equal to 8. Now, as we look at this equation, the left-hand side, when we start, is factored. But it's not set equal to 0, so we can't immediately apply the zero product principle. In fact, we'll have to expand the left-hand side, set it equal to 0, and then refactor it. So let's get started on that. We have y times 3y plus 2, and 3y plus 2 is in parentheses, that's equal to 8. So the first thing that we need to do is expand that left-hand side. We'll do that by distributing this y across 3y plus 2. And that will give us 3y squared plus 2y equal to 8. Now at this point, we need to set the equation equal to 0. We can do that by subtracting 8 from each side. And that will leave us with 3y squared plus 2y minus 8 equal to 0. Now, our equation is set equal to 0. We need that left-hand side factored. With 3y squared plus 2y minus 8, we'll need to use the AC method in order to factor that expression. So, a times c in this case will have 3 times negative 8. So AC will equal negative 24. And we'll make a table of factor pairs of negative 24. And we're going to be looking for the pair whose sum matches our middle term, which in this case is 2y. So we're going to need a pair whose sum is 2. So going through, to have a product that's negative, one of these pairs, one number in each pair will need to be positive and one will need to be negative. So we can start with 1 and negative 24. We see that that sum's negative 23. We could do negative 1 and positive 24. That would be a sum of positive 23. We could do 2 and negative 12. That'd give us a sum of negative 10. We could do negative 2 and positive 12, and that would give us a sum of positive 10. We could do 3 and negative 8 to get a sum of negative 5. That wouldn't work. We'll try negative 3 and 8 for a sum of 5. Of course, that doesn't work either. We could do 4 and negative 6. That would give us a sum of negative 2. Negative 4 and positive 6 will give us a sum of positive 2. And so those are the two numbers that we're going to need to use to expand to y. So coming over to our equation, 3y squared plus 2y minus 8. We'll now write that as 4 terms with 3y squared minus 4y plus 6y minus 8. And that's all equal to 0. Now we can use factoring by grouping. We'll group the first two terms and the second two terms. So we'll have 3y squared minus 4y. That's in grouped in parentheses, plus, and then grouped in parentheses we'll do 6y minus 8. We'll now look at each of these pairs separately and factor the greatest common factor from each pair. So for 3y squared minus 4y, we can factor out a y. That'll leave us with y times the expression 3y minus 4. Going to our second pair, we have 6y minus 8. The most that we can factor out there is 2. So we'll have 2 times the expression 3y minus 4. And so that equation is still equal to 0. Now, 3y minus 4 is a factor of each of these pairs. So I will factor that out, and I'll have 3y minus 4 times y plus 2 equal to 0. So I have the factor 3y minus 4 grouped in parentheses times the factor y plus 2 equal to 0. So now I have the product of two things equal to 0, and I can apply the zero product principle. So from that zero product principle, I can now write that 3y minus 4 equals 0, or y plus 2 equals 0. Solving 3y minus 4 equals 0, I'll get 3y equal to 4, and then that'll mean that y is 4/3. Solving y plus 2 equals 0, I'll have y equal to negative 2. So I now have two proposed solutions, 4/3 and negative 2. So I'll check each of those. I'll check y equals 4/3, and I'll do that by replacing every instance of y in the original equation with 4/3. So I'll have 4/3 times 3 times 4/3 plus 2, and that 3 times 4/3 plus 2 is in parentheses, and I'm checking, does that equal 8? Going through that arithmetic here, I'll have 4/3 times, and then inside parentheses, 3 times 4/3 is just 4. So inside parentheses, I now have 4 plus 2. I'm checking, does that equal 8 still? And this becomes 4/3 times 6, which we know does equal 8. The next solution that we'll check is -2. So every instance of y in the original equation we'll replace with -2. So we'll have -2 times 3 times the expression -2 plus 2. So we have -2, and then inside parentheses we have 3 times -2 plus 2. We're checking, does that equal 8? Simplifying that, we'll have -2 times -6 plus 2, and -6 plus 2 is inside parentheses. We're checking, does that equal 8? And we'll get -2 times -4, which we know does equal 8. So both of those solutions have checked. So now we can state our solution set. The solution set is then the set containing the number 4/3 and -2, which we'll write as curly bracket 4/3 comma -2 with another curly bracket.